So today we'll be looking at function transformations, and we will be taking our function by selecting a few data points from data that measures the atmospheric carbon dioxide at Mauna Loa Observatory. And as you can see, from the years 1960 to 2013, it is steadily rising in its general tendency, but you always have little up and downs. And when we zoom in a little bit to the years 2008 to 2013 over here, then we can see a little bit more the ups and downs, but still see the general tendency of the carbon dioxide in the atmosphere increasing. Now we are taking one of these or two of these up and downs from the data and focusing and creating a function from there. So here in our first example, we're basically just solidifying our function f of x, and we're defining x as a number of months after January 1, 2011. That means when x is negative, we're looking at data before January 1st, 2011. And if it's positive, we're looking at data after January 1. And then y, so our f of x value, is then the amount of carbon dioxide in the atmosphere. And if you looked at the values, they were relatively high. And so we will be taking a baseline of 380. So you're looking at our data value above 380 in parts per million. And so our numbers are a little smaller and easier to work with. So you see the data we are focusing on in this graph as well as in this table, and so we'll be doing both. We will keep looking at the graph as well as the table for all our function transformations. And just to understand a little bit what we are looking at here then in our graph. So when we have x, right, so this is our x value and on the horizontal axis. So when x is negative 15, that means we're more than a year before January 11, and that would actually be September 2009. And then our last data point is then when x is 9, and that would be September 2011. Now our y values reach somewhere, right, so a little bit above 0, looks like 4, all the way to up to 13, and that always means above 380, so from 384 to 393 parts per million. And in table 1 we see our exact data points, and those are the ones we'll be using in this video and as our function f of x for all the considerations we are doing now. So let's get started with vertical shifts. This is something you've seen already, and we are looking at our function value f of x, and we are adding 4 to it, and we're going to take a look what happens. So we'll be looking at the graph first, and we're looking at our x value and our y value, and we think about what happens. So our x value remains the same, and our y value gets added 4 to it. So when we do that for our first point is negative 15, 4, then if we add 4 to that, it will now be at y equals 8. So all our points have shifted up, and we are now just going to make the graph, and then all we need to do is connect our data points. And so here we see that our graph just simply has been shifted up 4. Now, if graphing is not quite your thing and visually understanding how to shift the points, let's focus on the table here. I found that helpful to first write out the points and then just simply transfer those points onto the graph back. So we are having here our exact data values written out in table form, and then the first thing we're going to do is write out our corresponding points. So the first point would be then negative 15, 4. And then what happens to that point is that our y value gets added 4. So it becomes, the x stays the same, so negative 15, and then added 4 to our y value. And then we now can do the same thing with all the other points. I invite you to fill them out as well to start practicing doing that. So now we have all our values filled in, and we could now plot them. So we could do it the other way around. First fill out the table and then graph. And you will find which works better for you, and I will do a little bit of each of them as I'm going to show all the different transformations that we can encounter. Now, what does this mean? It's basically all our carbon dioxide values have risen by 4. So if there's a general shift up then in all the values, then that is how we could express that as our f of x plus 4. So our function is shifted up by 4, and so what it means in our data set is that our carbon dioxide values have increased by 4 parts per million overall. Now, what happens when we have minus 2? You probably have already your guesses, and so instead of plus 4, we're going to look at minus, taking our function value and minusing 2. So I'm gonna this time around start with the table, and I'm gonna again fill in all my points here at first. So that's my first point, and in the same way I'm just gonna fill in all the rest of my points. And now I take my y value and I minus 2, right? Because I take my function value f of x and I minus 2 from it, so I get for our first point negative 15, 2. And then from there on I fill in all the rest of the values. And now that I've made my points, I can now do it the other way around, and now I just take my points and I graph them on my graph. So I find negative 15, 2, and then negative 9, 10, and you see graphically what happens. Everything again gets shifted down by 2, and so I have a similar situation as before, just down. So we can conclude from here that if we are adding a number to our function value, just like here in f of x plus k, value k, and if k is greater than 0, this scenario, then we're shifting up, and if k is less than 0, so when we had minus 2, right, then the function shifts down. Now I did not yet fill in the meaning of our function here, but it's basically the exact same. So instead of our carbon dioxide values being increased, they are decreased now. So these were our vertical shifts.